Okay?
Thank you, madam. Thank you, madam.
Yeah, sure. We will.
Muktadi,
Hi, Dr. Ravinder.
can you start?
Sure. Sorry. Actually, I was a bit confused about the timing between the Australian and Indian time. So I thought my
Muktadi, before you start, I would like to play one video of our student, okay, who will introduce your research. His research, okay. So I would like to play one video, okay. So after that, you can start, okay.
Sure.
Okay, thank you.
I, Revati, is doing my full-time PhD in RF and microwave domain. My research topic is design and analysis of high-efficiency Retina. Retina is nothing but a type of antenna. So my research is supervised by Dr. H. Uma Habiba, Professor, Department of EC, Bharath University. So I am here to share my views on my research journey under the international workshop organized by Bharath University on research methodology and engineering approach. So my research journey started back in 2014 when I was doing my master degree. So at that time, in the first year, we had many courses. In that, we had a course related to RF and microwave, so which inspired me more and which attracted me to do my project in the second year on antenna design. So in the second year, we had a project to be done for 6 months. So at that time, I chose my guide for doing the project in antenna design. So at the time, I met my supervisor. So we both started doing research in the antenna design. I started with modern antenna designs for various applications. So basically, the design and analysis of multiple modern antennas for various terrestrial applications were done, and followed by that many I attended many conferences and published many papers based on the design and analysis part we had done. So after that, while entering PhD, so I thought of continuing that research based on the antenna. So, but I had an idea of doing under energy efficiency, so which is a vital part in today's society, energy efficiency. So we went into extension literature study for that. So and found that design of Retina can be done. Retina is nothing but a combination of an antenna and a rectifier, which acts as a sensor. So which can be used for RF energy harvesting for powering up various devices. It can be used both for terrestrial and space applications. So my research, I did both terrestrial and space, but my PhD is basically concentrated on the space applications for powering wireless sensors and satellites. So after doing that extensive literature study for the first 2 years of my PhD, parallelly I did chose my coursework related to the research and completed the coursework. So after that, the design part starts. So we started designing the antenna rectifier altogether. The Retina we started designing, and then followed by that we went to the simulation part. So after optimization, tuning, and it took around 6 to 8 months to get a final Retina to be made. That is the simulation part. And then after getting a perfect results on the simulation, satisfied results, we moved on to the experimental part. That is after we did fabrication part, we did fabrication of the antenna rectifier and then combined together to act as an Retina. And then we did the measurement. So for measurement, we faced a lot of challenges in measurement also. So in design also we faced a lot of challenges, because in the design part we took elliptical shaped design of an antenna. So we don't have that much formulations for formulations for designing that antenna in the literatures. So what we did is we referred many books, and we referred many many articles, and we derived that equation for designing the elliptical part, and then that was the first challenge I faced during my research. After the design, the simulation part also, many challenges were faced by us, because either designing the antenna or designing the rectifier is easy, but separately designing the antenna in the layout and separately designing the rectifier in the schematic and combining, co-simulating these two and making them to work is very tough one. So it has many steps and procedures. My guide sits with me, and she gives me many documents for making me to understand the procedures, and we used to work together. And then after that, after designing simulation, we come to the fabrication part also. The raw materials, for fabricating the antenna, the substrate laminates was not available in India, so we used to search for the substrate laminates, and we used to order that. It took many months to reach us, and then we go for fabrication. Likewise, the rectifier part also, the components, we went for SMD type components. So for those components, we used to order through various companies, and it will take time to reach us. And after getting these raw materials, we go in for the fabrication. So after fabricating, the testing part is the most vital part. In testing also, we face many challenges, like we thought of doing the testing as such, how it will be in the space. The real-time environment should be brought to the reality. So we did testing like the real-time environment, how it will be in the space, like the distance between the prototypes testing. So these things we kept in mind. So many challenges were faced there, because a ready-made testing environment will not be available. So we need to purchase the raw materials for those things, testing also, the wires and all the things, and then we go for testing. So in first attempt itself, we won't get better results, because during the fabrication process, the proper connector, choosing the connector, the proper substrate, the proper placement of components, soldering, everything matters. If one thing goes wrong, we won't get the proper result. So multiple times we will use to go for fabrication and testing. So after achieving the proper results and comparing the simulation and measurement, after we get satisfied, we move on to the writing the paper and publication part. So this took us around 3 years totally. So after doing this, we and a special mention is that we had a research group in our college, along with Uma Habiba madam, and we have bachelor students, master students, and PhD scholars. We work together in our college, so we share our thoughts, and working in group gives, we stay alive, we stay focused, and many inputs will be given by many people. So it will be it was a good time there. So after that, we went into the publication part. So the publication is, we write paper and we sit together, myself and my guide sit together. It took multiple times to do the correction. So and then the first paper got selected in IET journal, that is IET Communications, and the title of the paper is High Performance Antenna for Energy Harvesting in a Satellite Health Monitoring System. And followed by that, in next year, another paper in a circuit world, it got selected. The title of the paper is Energy Harvesting Wireless Sensors for Achieving Self-Powered Satellite Health Monitoring System. So these two journals are listed under Annexure 1 Journals of Anna University. So after publication gets over, we started writing the synopsis, so which is an important part. So synopsis and followed by thesis. So now I am in the stage of submitting my synopsis. So this is my research journey in the past 5 years, and special thanks to my supervisor, Dr. Uma Habiba, and Bharath University for giving me this opportunity to share my views on my research journey. And thank you once again.
Good evening to all. I am here to give an introduction about our today's speaker, Dr. Muhammad Muqtadir Rahman sir. Sir is a senior power system engineer at NG Team Power Technology, demand side management, renewable and power system specialist. Wollongong, New South Wales. Sir is a field hardened professional electrical engineer with more than 8 years of experience in the power and renewable energy engineering industries. Sir has a solid knowledge and experience in power systems, steady state and dynamic studies, grid connected renewable energy integration and demand side management. He is a proficient user of DigiSilent Power Factory, PSCAD and PSSC software for power system planning, modeling, designing and connection studies. He has substantial experience in the provision of energy management, efficiency and conservation techniques for the residential, commercial and industrial sectors. Sir has experience in collaborating and consulting with the clients for normal power systems and Australian energy market operation on regular basis to develop strategies and timely recommendations for progressing the connection process for the generator plants. Sir provides responsible technical support for during R2 stage for the large-scale solar farms. He also provides a deep level of technical explanation and analysis about the inverter and power plant controller performances during the design and commissioning phases of solar farms. Sir is experienced in collaboratively working with R&D engineers in developing new control techniques to increase the penetration of the converter-based generators into the weak grids and providing training to junior engineers, sales engineers, and field technicians. Sir, I hand over the session to you to proceed with your presentation, sir.
Thank you, Mrs. Kalasevi, for introducing me in this presentation. Just wanted to check if you guys can hear me clearly.
Yes, sir.
Okay, do you want me to turn on the camera or is it okay to switch off the camera?
Camera on, sir.
Yeah, can you hear and see me clearly?
Yes. Yes,
Okay.
sir.
Yeah, thank you. Just wanted to check that how long I have the time to speak.
Sir, 40 minutes.
Okay, so it's quite enough time.
Because your second speaker is also online.
Okay. Sorry, it's been confusing for me because of the time difference between Australia and India. I thought the presentation would be tomorrow, so I had to quickly prepare my presentation in a short period of time. So it should be enough to deliver this piece in 40 minutes. So I just want to share my screen. Okay. I'm not sure how to make this bigger. Can you seeing in my computer?
Yes. Our main PV server.
Okay, maybe I do again. Stop sharing. Just to give me a moment. I'm not used to with this WebEX meeting. I'll do it again.
You also.
Okay.
Yes, sir.
I think you
Okay.
can see my screen now, right? Okay. So yeah, so today's topics, I like to discuss about the issues and challenges related to the large-scale solar PV integration. So I think is a very hot topic currently in the market, and the renewable market is growing rapidly globally. So to integrate the large-scale PV penetration into the grid is there are many challenges associated with that. So I like to highlight that in this presentation, and also we'll cover some research and research topics that need to be focused on in future. So I just categorize the presentation in different index about my current company, that what they do and how I involve and what technology they provide, and the introduction a little bit about the renewable industry and the key solution for economic loss related to the solar plant, and the solution for other economic losses, and the challenges and solution related to renewable integration into weak grids. This is another key topics to discuss, and finally question and answer. So the Inge team is one of the large manufacturer globally. It has around 20 offices in 24 countries. So mainly this company provides the power electronics, electric machine, automation, and OEM service. And we have a big laboratory for wind, solar, hydropower, marine power transmission, distribution, railway traction. So all the power and conversion and automation technology, the company provide the technological solution. So currently in Australia, it has support. I'm actually involved almost 3 gigawatt renewable integration in Australia, but in globally, this company actually supported 18 gigawatt PV inverters. So this is the large scale inverters. So it has a product of hydropower system 8.6 gigawatt. So you can see wind energy 45 gigawatt installed white rolling. So basically the company provide the converter technologies for this solar and wind hydropower. So I'm not going to discuss more details on that. So mainly for the large scale solution, like I just wanted to highlight here that what kind of technology for the solar we introduce. For example, here you can see this is the large scale central inverter concept. So it comes with 2 inverters, and sorry, it comes with 4 inverters, and each inverter has 1.64 megawatt capacity, or you can say 1.64 MVA capacity, and it's connected with the transformer and then the RME and switch gear. And actually, basically, it comes with the container solution and directly plug into the grid. So this is a plug and play solution that normally we provide globally. And there's a new solution just recently came up, is about the water cooling system. So normally in the previous solution, the inverter cooling system is by air, but now we introduce a new solution related to liquid cooling system. So basically, the IGBT and internal electronics will be cooled by the liquid system, so that can give you more robust support. There will be less derating in the power when you have a huge high temperature in the field. So it is a new solution, and it provides more power density compared to the previous solution. For example, here it has 2 inverters. Each inverter can still provide 3.64 megawatt, so double the capacity. So the next slide. So I just want to talk about in globally global renewable energy integration. So as you can see that from 90s to 2026 forecasting. So the growth of renewable energy is very high. This is very, very, very high, and compared to just excuse me, I guess I'm cold. So yeah, sorry for the distraction. Okay, so solar, wind, hydropower is growing a lot, and compared to 90s and to 2020s. So This is a good picture to present that how renewable integration is growing globally. And then I just wanted to highlight it here some new update about the solar panels in globally. As you can see, there's the top 10 solar panels currently in the market. So the top one is sun power. The efficiency is 22.70%, and LG is 22. It is closely like they are more almost close efficiency measurement. So, and the top one is high price compared to the second and third one. So as you can see that the maximum efficiency from the panel you can get up to now in the market is 22.70. I think there are some panels are under research. They can provide a little bit higher value, but they are not in like a in a huge huge sale in the market. So these are the more common that you can see in the market. Okay, so a little bit I'd like to talk about what is happening in Australia and why I'm going to say this is the economic challenge that the solar plant owner are facing. So, for example, in Australia, 2000 compared to 2010 and 2020, you can see the massive growth of renewable integration. And on your right-hand side, you can see that there's some beautiful color picture, but this is some there are some scary news here. For example, the green line represent the system strength, the orange is economic. So, for example, what is happening? Economic curtailment. So in 2000, let's say in 2022, as you can see that the economic losses or the curtailment of the solar plant is at a megawatt scale. So up to 50 to 150 megawatt solar power or the renewable connection was curtailed because of the negative price during the day. So during the day, when there's less demand, then the AUMO, which is the regulator or the NSP, the operator, they actually curtail the solar plant to a certain level because of the economic losses or the market price is negative. So the plant owner, if the plant owner generate the power, then they will be negatively or they will be get penalty to produce the power. So they need to curtail the production. While it is important to have renewable integration throughout the day. So this is the economic loss for the plant owner. So there's another reason that system strength curtailment. That means the grid is in a certain situation is not capable to handle that amount of renewable integration in that certain period. So the NSP or the regulator, they curtail the solar plant during some period of time. So this is the economic loss also for the plant owner. And there's other curtailment reason, as you can see here. The reason other curtailment reason is, for example, like there's a outage in the grid or congestion in the grid or other network constant issue. So they curtail the plant. So as you can see, these figures, this figure represent the huge amount of energy, solar integration curtailment from 0 to almost 200 megawatt for only this Q4 in 2020. So you have more on the left hand side. So in 2021 and 2022, there are more. So there are like many reasons: the economic curtailment, system strength curtailment, and other curtailment. So basically, you have a solar plant or wind plant, but where you're forecasting to get revenue, but because of this issue, you are not getting revenue. Actually, you are in economic loss situation. And what are the solutions for that? So what are the potential solutions to cover these economic losses? So the now currently in the research area and in the market, there are few solutions have been advised or have been considered. For example, one is in the existing solar or wind plant, you can connect the DC coupled storage solution, AC coupled storage solution, and the utility scale green hydrogen solution. This is a new topic. And adding synchronous condenser in some sensitive location. So that can give you system strength support so that the curtailment of the solar or wind will be less. So I'm going to discuss about each of the items, and we'll tell you that what could be the the potential research scope, what are the challenges related to these technologies. For example, this is a PV plant with a DC coupled storage. So, for example, this is a PV inverter. So normally, let's say you have a solar PV plant with the inverter and connect to the grid, okay? And the inverter is controlled by the power plant controller that actually globally controls all the inverters in the plant. So what happened, like during this economic reason or system reason, during the daytime, the plant has been curtailed. So you have energy from the PV, but you are not producing to the grid. So during those times, you can actually supply to the battery, and you can charge the battery, and when during the night time you actually discharge the battery. So this is the one solution, DC coupled solution. So the challenges is related to you need to have a high PV sizing capacity to support the battery charging, and we don't know the actual cost if you go with this solution. And another one is like a PV plant with the AC coupled solution. So here you have a PV plant, but instead of connecting to the DC side, the battery will become directly to the AC side. So there will be a transformer. So the challenges here compared to DC couple and AC couple, what could be the best solution? For example, in the AC couple solution, the inverter can give you reactive power support during daytime and nighttime. But in the DC couple solution, the DC converter will not give you reactive power support. Only the inverter will give the reactive power support. So here in the AC couple solution, you have the reactive power support from inverter, two inverter. One is for PV, one is for the battery. But the challenges is you need to add a transformer. So how cost effective would be compared to DC couple and AC couple solution? That could be a research question, and that need to be identified that which solution is best and cost effective. So the green hydrogen is a new topic. So as you can see, as you know, that the hydrogen solution is getting more popular. So you have electrolyzer, and then you have a PV plant connected to with the rectifier, and use the electrolyzer during when there is a negative price. You can use the electrolyzer to charge a system, and later on you can use it. So yeah, this is the new solution, and this is currently in the market. So there is more research to focus on how cost effective and in the technique and also the technically viable solution it is. And okay, so this is a synchronous condenser solution. So as I showed you before, that the system strength issue because of the grid is weak, they cannot support the renewable energy integration. So synchronous condenser can give more short circuit power, inertia, the connection point. So it will be an alternative solution, but the cost compared to this AC/DC, the solution, this is need to be considered, and also need to do economics, assessment as well as the technical assessment. For example, as compared to the performance of the STATCOM as compared to STATCOM and the battery solution, you can see that voltage fluctuation support is very high, short circuit current also high, and you can see the comparison between the Syncon and the STATCOM is almost same, but sometimes it's low and sometimes it's higher based on the criteria you have chosen. Okay. So for the large scale solar or PV, solar or wind integration into the grid, there are a few things are required to support the grid. So which are LVRT, HVRT control support, fast frequency regulation support, voltage loop control or automatic voltage regulation support, voltage oscillation damping, and also benchmarking between the simulation result and the field testing result. So what I'm saying here, so before you connect or commission any large scale plant, you need to do a simulation study and comply with the grid code, and then you do the field test and compare between the simulation results and the field test result, and that's both test results should need to be accurate enough. So, for example, here's LV support system. As you can see, this is a three-phase fault and the two-phase fault, ground fault. So for the large scale solar or PV, solar or wind, when you have a three-phase fault, you can see that the red one is just a normal inverter concept, and the blue one is the India team that manufactured the inverter. As you can see here, during a fault recovery, you have a huge spike, but with the indicative technology that we developed, the spike is reduced, because if one solar plant is giving you this spike, imagine that there are multiple solar plant or hundreds of solar plant, and if they provide, all the solar plant provide a huge spike, that gonna be a huge problem for the grid. So the spike should be reduced. So we have the technology that during the fault recovery, the spike will be reduced, and also there's a new thing into the market. The new requirement is all the large scale solar or wind, they should provide negative sequence current during an unbalanced fault. So here the figure you can see here that during a two-phase to ground fault, the negative sequence voltage is up, and you can see the negative sequence and positive sequence current is applied here. So usually, like 1 year ago, there is no requirement of the negative sequence current injection, but the new requirement is the negative sequence current and positive sequence current need to be injected by the converters. So if you inject negative sequence current, then that means your positive sequence current will be reduced. So there will be another economic loss, but this current injection is a very short period of time, let's say within couple of 100 milliseconds. So the impact would be minimum. Okay, so the fast frequency regulation support is very important to provide at least some primary frequency support, because when your fossil fuel based, or for example synchronous generator are reducing or displaced by the renewable integration, so someone need to provide the primary frequency support. So now the requirement is all the large scale plant, renewable plant, they need to provide the primary frequency support. So as you can see here, it's a simulation based. So for example, if the frequency goes up from 50 to 51.5, as you can see that the active power drops significantly to zero within 500 milliseconds. So this is very fast. 500 milliseconds is quite fast. So this can provide the primary frequency support. And in the same time, when the frequency drop, for example, when the frequency drop, the plant should provide the frequency, the active power support if the plant has extra capacity to provide. Okay, so finally, another requirement is enhanced voltage disturbance control. So for example, here, when you do a voltage step test, for example, if the grid voltage is moving from 1 pu to 1.05 and coming back from 1.05 to 0.95, so if the grid voltage is moving, how your plant is reacting with the grid voltage movement. As you can see here, the red line is like a normal inverter, and the blue one is the in-game inverter. As you can see, the steps are very smooth. There's no harmonics elements here, and also you can see the reactive power movement is very smooth compared to the little spike. So the variation is very smooth. So this is very important, because when you have a multiple or 100 plants are connecting together, so if the plant is giving this spike, then you receive there will be a problem for the grid. So we don't want to create problem for the grid, and it will be you will be curtailed because of the system strength issue. So the plant response should be smooth. So yeah, so there's technology behind, more research is behind how to improve the inverter performance during this voltage variation. And another thing is, as you can see, this is the recommend, because of simulation results, they need to be verified with the field results. So before any plant commission in the real field, so there are many simulation results to comply the grid codes, and then once you verified, and then you are allowed to connect commission your plant, and then you do the same test what you have done in the simulation. So as you can see, the blue one, this is quite interesting to show you that how the simulation results, or how the simulation models have been developed to accurately represent the real solar plant. So as you can see here, and the blue one is a measured value, and the yellow one is a simulated value, and the dotted line are the error band. So we consider the 10% plus minus 10% error band. As you can see, so the simulation results and the plant response are very, very close, are within the error band. So for example, as you can see here, active power is slightly outside because of the clouding movement. The active power is moving. So this is small variation is acceptable. So another interesting to share with you here, that while we are trying to match with the simulation result and the real field result, for example, the blue one is a real field, and the red one is a simulation result. As you can see, the reactive power variation is perfect, while active power is not perfect. There's a huge drop in the real measurement compared to the simulation result. This is because in the simulation, you cannot represent the clouding moment. So, but in the real field, in a big solar plant, there will be a huge cloud movement from one side to another side. So because of the variation, you can see the active power. So this is another challenge with the simulation model, how to replicate this clouding behavior in the simulation. So it still need to be investigated. So how we can actually represent that clouding movement in the real field. Okay. So now another interesting topic to discuss: what is a weak grid and what is the system strength? So because the weak grid is very important to know how the weak grid work and what the weak grid means. So weak grid means like the grid, your point of connection and your generator site has a huge line between your point of connection and your generator, like for the synchronous generator or the base generator. So the impedance is high and the short circuit power is less. And of course, we define a parameter called short circuit power, short circuit ratio. So short circuit ratio, for example, this is your Thevenin impedance, like this is represent your grid, and then say the grid impedance. This is the way we do simulation, and then it's a point of connection where your plant will be connected. So if the grid impedance is very high, that means your system is weak. That means the voltage drop, and the voltage will be moving a lot if you inject current from your solar plant or PV plant, a solar plant or wind plant. So how we define this is a weak grid or a strong grid? There is a parameter called short circuit ratio. So it is actually short circuit power at point of connection and divided by the plant MVA. So if the HCR is high, then we see that the point of connection is strong. So what is the number we say? That if the value is less than 3 in this point, this ratio, we mean so that the plant, the connection point is very weak. Also, the XR ratio of the impedance has a lot of impact. So we'll discuss later on. Okay, so for example, here I took some picture and try to show you here what is happening when you connect your solar or wind plant in a weak connection point. So currently, the current technology is a grid following technology. In the grid following technology, we use PLL, the phase lock loop technology, which track the grid voltage angle, and according to this tracking angle, the converter inject the current. So, for example, when the PV inverter connecting the weak connection point, let's say the SCR ratio 1.7. Remember, I said that if the SCR is below 3, the grid is very weak. So here we can say the SCR is 1.7. And what is happening here? When there is a fault happen, and when the fault recover, we see that the huge voltage spike and the plant is oscillating. So this is not good for the grid. And similarly, you can see on what's happening in active power and reactive power. So it's not recovering to the pre-fault level, pre-fault voltage and pre-fault active and reactive power is oscillating. When the SCR is below 1.5, you can see huge oscillation during before and after the fault, and the PLL cannot track this huge movement, huge voltage movement. So and it provides the wrong angle to the current controller. So this is not good for this grid following converter technology. So and what is the solution when the grid is very weak, and what technology we can use to support the grid? So this is another example, like when your inertia of the grid is decreasing, your rate of change of frequency is increasing. So basically, you can see here when your rate of change of when your inertia is decreasing, the rate of change of frequency is very stiff. So there's a direct relationship between the rate of change of frequency and the inertia. So normally this converter technology, the grid following technology, they cannot provide the inertia support of the grid. So if the less inertia of the grid, that means the frequency will be moving a lot. If the frequency moving a lot, the PLL have difficulty to track the grid angle and frequency. So for example, here in Australia, what has happened in 2005, the frequency variation is between 49.95 to 50.05. So it's very less. You can see the frequency variation is very less. When the more and more renewable energy start connecting, especially for the grid following converter technology, you can see the frequency variation, the bandwidth is very high. So that means the frequency oscillating between 49.85 to 15.85. And so more and more renewable integration into the grid, these curve will be way beyond here. So it's more problems. So frequencies are moving a lot. So this is not good for the grid. So this is a summary of some technology that can help to support the renewable integration into the grid. So for example, the system strength, the grid strength, how we can increase the grid strength. So the synchronous generator, but the synchronous generator is is now displacing by the grid form the renewable technology. So the next available solution is grid forming battery storage solution, synchronous condenser that can provide the inertia and the grid support, and voltage control. So there's another technology base, the SBC STATCOM, frequency control. You can do the frequency control and inertia support, grid forming, as well as synchronous condenser. So this kind of technology can help to support the renewable integration into the grid. So, for example, here, what is happening with the grid forming technology, the converter, currently in the market. So it actually had to log the grid. So if the grid is moving a lot, the PLL cannot track the grid. And if the PLL cannot track the grid, you can see after the fault recovery, it's going to oscillate. And with the traditional grid forming is the voltage source converter. So it creates its own voltage, so you don't have to track the grid. So, but now we're not talking about traditional grid forming technology. We're talking about new kind of grid forming technology that can provide inertia support, voltage control support, and any other like a dynamic support. So, for example, here you can see that it can adapt its control, track the grid. So as you can see, during the fault and after the fault recovery, it recovered the fault to the pre-fault level. And there's the synchronous condenser. It also has the technology to support high short circuit power and the inertia to the grid. But still, this technology is very expensive, and also is compared to the current grid forming technology, and compared to this, yes, still there's some oscillation, and the oscillation could be more and more in different circumstances. So this is just a typical example, but it doesn't mean that the grid forming and the synchronous condenser, the grid forming technology is superior to the synchronous condenser. It depends on some situation and the grid condition. So yeah, I think up to now, my presentation has finished, and I just wanted to share something with you, which is at the end of the page. So basically, this is a typical simulation model before we commission the plant. So we do simulation studies. So as you can see, this is a PSCAT simulation model. We use the aggregated inverter model that represent that hundreds of inverters, as you can see here, and then it's connected to a LV transformer to step up voltage from 630 voltage to 33 kV, and then you have a power plant controller. We define the active and reactive power capacity of the plant, and then it connects to the grid. So the challenges is simulation models are aggregated inverter model, but in the real field, inverters are separated between the lines. So this is the challenge. So you cannot put 100 inverters in the simulation to run, but you still need to accurately represent between simulation results and the field results. I think, yeah, up to now, which is finished my presentation, and I'd like to hear some question from you if you have.
Good evening, sir. Sir, when we are making solar panel, in recent research, material cost is very high generally. So any recent material came with low cost so that we can make solar panel for a home or for a industry purpose with low cost. And another question, we want some sample. Suppose if it is 1,000 square feet, how much power can be generated? For which are the purposes it can be used?
Okay, regarding your first question, I'm not sure that the current my research is not on the solar panel materials, so maybe I have limited knowledge on that. But I can help you answering this question. If you can send me through the email, I can help you with that. And regarding the second question, normally I would say, for example, recently we have a plant with 100 megawatt plant, solar plant, and this 100 megawatt plant requires 300 acre of land. So basically this is the estimate size. Yeah,
Thank you,
is that
sir.
answer your question?
Thank you, sir.
Okay.
Thanks for sharing your experience and idea in power system energy management and your studies on grid. Thank you for the session, sir. It was a very nice session.
Thank you. I hope you enjoyed the presentation.
Yes. Thank you, sir. Thank you so much.
Thank you.
So our next session speaker is Dr. Himal A. Suravera, sir. Sir has received his BSc Engineering First Class Honours degree from University of Peradeniya, Sri Lanka in 2001 and the PhD degree from Monash University, Australia in 2007. Currently, he is a senior lecturer at the Department of Electrical and Electronic Engineering, University of Peradeniya, Sri Lanka. From January 2011 to May 2013, he was a postdoctoral research associate at the Singapore University of Technology and Design, Singapore. From July 2009 to January 2011, he was in the Department of Electrical and Computer Engineering, National University of Singapore as a research fellow. From February 2007 to June 2009, he was a research fellow at Victoria University, Australia. His academic achievements, including receiving the Molly Holman Medal, Kenneth Hunt Medal upon graduating from Monash University, and the IEEE Communication and Society Asia Pacific Outstanding Young Researcher Award in 2011. He received an IEEE Communications Letters Exemplary Reviewer Certificate in 2009 and 3 IEEE Wireless Communication Letters Exemplary Reviewer Certificates in 2012, 13 and 14. And IEEE Transactions on Vehicular Technology Top Reviewer Award in 2013, 3 IEEE Transactions on Communications Exemplary Reviewer Certificates in 2014, 15 and 19, and 2 IEEE Transactions on Wireless Communications Exemplary Reviewer Certificates in 2017 and 18. Dr. Suravera sir is currently serving as an editor for IEEE Networking, IEEE Transactions on Communications and IEEE Transactions on Green Communications and Networking. His research interests are in the areas of wireless communications, signal processing for communications, and communication theory, in particular relay networks, energy harvesting communications, and massive multiple input, multiple output systems, full duplex communication, and cognitive radio. He is a senior member of IEEE. I welcome you, sir. The session is yours, sir. You can proceed with your presentation, sir.
Thank you very much, Mrs. Kaleselvi, for the kind introduction about myself. First of all, could you let me know whether I'm audible?
Yes, madam, you are audible.
Yeah,
Yes.
thank you very much. Unfortunately, I have some bandwidth issues, so I would prefer to do my presentation without switching on the video. I hope that it is fine with you.
Okay.
Thank you very much. Then the other question is like, are you all able to see my slides?
Yes, madam.
Ma'am, full slide view.
Yeah.
Thank
Is
you.
it okay now?
Yes, yes.
Yeah, thank you very much. So good evening to all of you. And first of all, I would like to thank all the organizers for inviting me to deliver this presentation. And it's my great pleasure to participate in this workshop. So my name is Dr. Himal Suravera. I'm from a Department of Electrical and Electronic Engineering from University of Peradeniya, Sri Lanka. So basically, I think the title of my presentation today is to discuss about the structure and the components of journal as well as conference articles and also postgraduate theses. I hope this content will be especially useful for postgraduate students as well as undergraduate students who are engaging in research. So with that introduction, let me move on to the second slide. Unfortunately, I think I have some issue moving these slides. Let me see what's the problem. When I put the full screen, my cursor doesn't work. What should I do?
Ma'am, you can
Yes,
click
sorry,
on
it's
this.
working.
Okay.
I have to double click. Yeah, so it's working now. Sorry about that. I think all of you know that prior to writing any journal paper or a conference paper or any sort of publication, we had to do research. So if you look into research, and let's say if you look into the definition of research in the internet, you will find different kinds of definitions. But I would like to highlight, what I would like to highlight is that all of these definitions resonate. Some synonymous words. For example, now I took this one from something called Code of Federal Regulations. It says as a systematic investigation of, let me see, this one is, okay, systematic investigation, i.e. the gathering and analysis of information designed to develop or contribute to generalizable knowledge. So if you look into this definition, you can see that gathering of information, you can highlight that part. And also you can highlight the part on analysis of information. And also you can highlight the part designed to develop to contribute to generalizable knowledge. So that means we normally we start research starting with some kind of a specific problem, and if possible we try to obtain results as much as possible that will generalize our understanding about that particular topic. So similarly, if you look into another kind of definition, which comes from the National Academy of Sciences, it says extend the human knowledge of the physical, biological, and social world beyond what is already known. So there you can see that that definition is also kind of synonymous to the previous one. It says when we do research, we extend our already existing knowledge into many different kinds of domains like physical, biological, and social, and so on. So, I think all of you might be familiar with these kind of definitions, but I just wanted to highlight prior to talking about the structure of journal and conference papers, right? So first we'll have to do research, and just to give a glimpse of what research is. So the next thing is, how do you select a suitable journal, right? So for example, there are no straightforward answers to this question, right? And later on I will explain you that say why this is important, because the structure of a journal paper varies slightly from one journal paper to another journal paper. So first of all, depending on your research, your supervisor or some of your colleagues will advise you to target a particular kind of a journal. So there's no straightforward answer. It depends on your scope of your research. And also whether the work is, let's say, biased towards theory, or whether it's biased towards practice, or a mix of both. Another thing that you need to consider, or at least you can think about, is the strength of your results. Sometimes you have preliminary results, sometimes you have research conducted for, let's say, about 1 year or more, some kind of a comprehensible kind of research work, and also depending on the findings, right? Whether these findings are specific or whether these findings are general and will be important to many researchers working in the field, and so on, right? And also, like say, the nature of your result, whether you want to disseminate your knowledge fairly quickly about your discovery, or whether you want to keep it for a while and then make it comprehensive and then try to disseminate among others and so on. So there are different kinds of aspects that you need to think before you select a suitable journal for your publication. So let me elaborate it a little bit further. So how much of results need to be reported, right? So most of the journal papers have strict page guidelines, restrictions. You cannot write it, let's say they will specify exactly how many pages you are allowed to write and so on. So that can also be another aspect that you need to consider. And also the recognition for your journal, the targeted journal among your peers. For example, now we have ranking systems for publications. So higher the rank, the more prestigious is your is the journal that you want to submit. And also a selection of a suitable audience, right? So that's also very important because some of the research findings might be very important to the academia, and some of the research findings may be suitable for let's say to the industry and so on. So selection of suitable audience is also another important thing that you need to consider. So some journals specifically cater for particular communities such as industry, policymakers and so on. And also another thing that you can consider is the level of feedback. So the higher the reputation of the journal, the amount of feedback that you will get seems or has a higher correlation to be high and so on. So now I will discuss a little bit on technical. There are different types of papers, as you all know, like say if you take journal papers. So the structure of a journal paper vary between, among these different classes or types of papers. For example, I think all of you might know about the original research work. Sometimes we call them as full journal papers or transaction journal papers in IEEE and so on. And also they report some type of a comprehensive set of results, normally which have been obtained over the course of a long period of time. It depends on the field. For example, in my field, research work carried out for, let's say, about 6 months up to 1 year. So then there are another type of journal papers, which we call as letter papers. So normally these letter papers are short and they are up to the point, and also they report a specific type of result, not many types of results, but a specific type of result. So they are called letter papers. Then you have something called magazine papers. So magazine papers are written in a language where the audience, the targeted audience is much more broader than a typical academic audience. And these magazine papers have special requirements. Something like, for example, IEEE Communications magazine. In IEEE Communications magazine, you cannot write a lot of equations, and the number of figures and the table should be less than or equal to 6, and the number of reference should be equal to 15 and so on. The idea there is to target a broad class of audience, people spanning people from academia, industry, and so on. So similarly, there are other kinds of papers which are called tutorial and survey papers. So in tutorial and survey papers, the idea is try to give you a general introduction to prior research or the state of art research that has been carried out in a particular, under a particular topic. So normally these kind of papers are very helpful for new postgraduate students to look for topics, research topics that are of current, relevant current topics. And then another kind of paper is the conference paper. And all of you know that it also helps you to do networking, because normally a conference paper is being written in a particularly short time as compared to a journal paper. And then you can go to the conference and present your research work and then get immediate feedback from the conference attendees and so on. Then you have things like technical reports and postgraduate theses, like MPhil theses, Master of Philosophy theses, Master of Research theses, as well as doctorate theses or PhDs, right? So let me move on. So now if I just want to talk a little bit on original research papers, right? So they are the papers that all of you are very familiar with. It's also called a full paper in general, and it reports comprehensive body of research. As I mentioned you earlier, it normally reports a research carried out, let's say at least 6 to 1 year. There's no particular timeline, but you will understand that you need to carry out a comprehensive kind of research to write a original research paper. And often this research is comprehensive, exhaustive, and also undertaken under a considerable amount of time, right? So the length of a full paper varies from journal to journal, and also it varies from field to field. For example, in my area, which is telecommunications engineering or wireless communications, normally original research paper spans, let's say, from about 9 pages up to about 16 or 17 pages, right? 16 and 17 may be a little bit rare, but often you will see papers in the range of 12, 13, 14 pages long. So there could be other fields where even it can go up to even 20 pages and so on. Right? And also it depends, different journals have different typesetting, different font sizes and so on. So depending on those also, the page length can vary. And also the review process of a full paper is much more longer, and it's quite rigorous because you are reporting something very comprehensive. Then if you talk about letters or letter papers, right? So they are, as opposed to full papers, right? They are relatively short. Sometimes they are 2 pages, sometimes 3, and sometimes 4 and 5, not more than 5. For example, some letters mention that up to 4 pages you can write your research content, and the last page you should dedicate it to only report the references, not the results, not figures and so on. So anyway, you will understand that it's a kind of a short paper, and letter paper is a short paper. So they are often describing a short point and something that needs to be require the quick attention of your research community. Having said that, some letter papers are very important, and sometimes they receive even higher citations as compared to a full paper for various reasons. Because sometimes if the result is so important to the community, to the research community of your field, right, they will tend to value that result much more than a comprehensive work. It depends, right? So likewise. So though short, as I mentioned, often writing letters are difficult, right? Some people might think that it's very easy because it's just 2-3 pages of writing, but soon you will realize that you also need to put a lot of effort when you are writing a letter paper. The reason is the content should be very short, and you should write to the point so that the reviewer will get the most important aspect of your research without getting confused. So it's not easy to write letter papers, although the number of pages is short. And improper writing, as I mentioned, often results in rejection. So basically, the decisions are binary. That means in letter papers, most of the time, it will be either accepted as it is or rejected. And in some journals, when it is rejected, you are given the chance to resubmit if the editor thinks that there is worth material to be published. And in other cases, it will be mentioned that rejected with no resubmission allowed. In that case, you are unable to submit your letter to that particular journal, and you should seek another letter to submit your results. So letters sometimes are more, as I mentioned, they receive more citations. Sometimes, not always, sometimes. And use of references as due to the page limit should be very, you should be thoughtful before referencing papers in a letter paper. The reason is that you don't have a lot of space. If you let's say cite about 20-25 references, you might not have sufficient space to report your research in a meaningful manner and so on. So you need to be very careful and you have to be very choosy when you are referencing in a letter paper. Also, you have to use figures, tables in a wise manner, and obviously due to a space restriction. And conclusions must only convey what is absolutely necessary. So often these conclusions in a letter paper is kind of short and up to the point as compared to an original research paper. And then you have survey papers. So in survey papers, the idea there, as I mentioned, is to to report something that has been done, or to reflect the state of the art of that particular field, so that a person, after reading a survey paper, will have a good understanding about previous research or any research gaps in the context of current time and so on. So often these survey papers are pretty lengthy, as well as they cite so many references related to that particular topic. The next thing is, let me see. So typical survey papers include hundreds of references. Also, they describe the historical progression of a particular research field, as I mentioned. So summarizes the most important results that have been obtained up to date, right? And discuss current problems that are worth to investigate. So that also helps postgraduates in finding new research topics and so on. So also well-written survey papers, I have observed that they attract a lot of citations because in a broader context, they are helpful for many people or many researchers working on that particular topic. So then I will go to magazine papers, right? So strictly speaking, they are technical magazines, not any other type of magazine. It's just a technical magazine. And mostly, as I mentioned earlier, these magazine papers are being read by professionals in your field, people from industry, policymakers, and also, academic professors and lecturers and so on. So the magazine papers are very popular in engineering field. Now, if you take IEEE, all sorts of societies have a particular kind of magazine. Now, if you take my field, like telecommunications, we have the IEEE Communications Magazine, IEEE Wireless Communications Magazine, and IEEE Internet of Things Magazine, and so on. So there are a lot of magazines, and they are pretty popular among the readership. So, as I mentioned, magazine paper writing vastly varies from, let's say, original research papers as well as letter paper writing. So you cannot include a lot of equations. If you have a lot of technical jargon, maybe it will be rejected and so on. So it should be written in a plain, simple language, as well as, but it doesn't mean that say you shouldn't report any technical things. Of course, that whatever you describe should be technical, but you should use much more simpler and plain words to describe these technical aspects. So I think all of you might have read magazine papers, and if you have not read magazine papers, I highly encourage, because even to write a magazine paper, you need a lot of practice as well as you need a lot of time. You might need to write many drafts and discuss with your supervisors and professors, and then try to edit them before you submit. Otherwise, you could there's a risk of rejection from the magazine editorial board. So, there are other kinds of avenues where you can publish, and one avenue that I can talk about is the journal special issues. So if you talk about journal special issues, every field or every field that you work on has some kind of hot topics. Hot topics means topics that are of high current popularity. So basically what some of the journals do is that they organize these kind of special issues, and they invite researchers to submit papers. So often, I mean, the editors in a special issue are called guest editors, and they are the people who are involved in this guest editorial board are well-respected scholars on that particular topic. So often in my field and in the publications that I submit papers, there are about, if there's a special issue, in some cases there can be 4 guest editors, in some cases there can be 5, 6, 7 and so on, but not more than 7 most of the time. So competition in this kind of special issue can be intense because it's a popular topic. Many researchers are working in that topic. So everybody wants to get a paper accepted in this kind of a special issue. So, but unfortunately, as you know, the amount of the material, or let's say the number of papers that can be accepted is quite limited. And in some cases, even if your work is very, very good, for some different reasons, it could be rejected. And if you submit that paper into a regular journal, or it could be easily accepted and so on. However, I highly encourage all of you to target time to time to submit to these special issues, because the rewards are pretty high, and in most of the cases, maybe you would be lucky to receive higher number of citations in the longer term for your research work. So special issues in general have strict timelines. So often, just like conference papers, you have to submit them under the described timeline. And often the work should be very, very highly polished, because normally in a special issue, you will be only given minor revisions. So if any work that requires major revisions will be rejected. So that's why I said that sometimes if you submit to a regular journal, that work could get accepted under a major revision, and after a while under a minor revision and so on. However, in a special issue, if the editorial board deems that your work should require a lot of, let's say, overhaul, definitely it will get rejected. Right? So initial submissions must be well prepared, and often only minor revisions are allowed. So papers that require extensive revisions are rejected. When multiple papers on a similar topic are received, let's say that myself and you submit a similar topic, right? The guest editors might pick a few than all of those papers, even though all of those work are up to the mark. So, I mean, that decision will be based on different conditions or factors. But anyway, you have to keep such things in your mind when you are submitting to special issues. So now I think all of you have a very, very good understanding of the different types of journal papers, conference papers, and so on. So basically now I think we are in a good situation to discuss about the structure of journal papers and structure of conference papers and so on. So if you take the structure of journal papers, as I mentioned, depending on different types of journals, depending on different publishers, IEEE, Elsevier, Eurasip, and so on, things can change a little bit, right? Those are, I mean, famous engineering publishers. They can, maybe there are minor variations, but most of these journals will have these kind of common things. So first of all journal papers will have a title, then you have abstract, you have keywords, you have the introduction, which is the section 1 of your paper, and then maybe in some cases you can have section 2 as the preliminaries related to your research and relevant work, or the literature survey, and then you start talking about your research, which includes are included in main sections, maybe section 3, 4, 5, and so on, depending on the level of research. And then you will have your results shown, and then you have to discuss about them, both the positives as well as limitations. Some people believe that say you should only talk about the positives, which is not true. Even if you talk about limitations, the paper will get accepted because any type of research will have some sort of limitation and so on. So putting all these things in a broader context will, I think reviewers will appreciate such a discussion rather than being a biased discussion only toward talking about the positives of your research and so on. So then finally you will have to have a conclusion. And then sometimes if you have, let's say, derivations that you cannot put in the main sections due to distraction of readability, right? You can put them in appendices. So interested people will read those results, derivations in the appendices and so on. And finally, also you will have references to support the paper. And if you look into the structure of a conference paper, it's pretty similar. You have the title, you have the abstract. In some cases, you have the funding footnote. Actually, the funding is also there. I might have missed in the previous slide. It's also there in the funding footnote. Should be there in the journal paper structure as well. And also you have the introduction and the sections, results and discussion, conclusion, appendices, and reference. So pretty much they are same as compared to a journal paper. The only difference is that you cannot, normally the conference papers are have shorter length, right? So they are about 5 to 6 pages in my field. And there are conferences in other fields which are a little bit lengthy, right? 8, 9, 10 pages, maybe not more than that, but it varies slightly depending on the topic, right? Or depending on the field. But normally a conference paper will be in some cases 4 pages, some cases 5, and in some cases 6. And also in conferences, they have this thing called the overlength charge. That means, let's say that the conference prefers to have your work for about 5 pages. And if you pay extra amount of money or a fee, you should be able to get another page extra. So altogether it will be 6 in case of 5 instead of 5, right? But anyway, it's a short publication as compared to a original research paper, original journal paper. So then if you talk about the final aspect, which is a thesis, the thesis is totally different from a journal paper and a conference paper. Normally you have the front matter depending on the university requirements, and then you have abstract. The abstract will be a little bit longer as compared to a conference and a journal paper, and list of acronyms and list of symbols, table of contents, and then the research, is mentioned in your chapters, right? Normally your thesis will have about 4 or 5 chapters, depending on the type of research that you have done. It's not a rule, but that is normally observed and so on. And then you have a conclusion and a future work chapter, which is pretty short, maybe maximum about 3 pages, 4 pages long, just to summarize the main conclusions and to outline future work. And of course, then you will have the references. And so, to be honest, in this presentation, due to the time limitation, I will speak about the structure of the journal paper and the conference paper in more detail as compared to thesis. So let's talk about the structure of a journal article in more detail, right? So first of all, like all papers will have a title, and these titles can vary. But some titles can be concise, that means short, and they should, in some cases, very specific. For example, let's say in my field, there is some, I can give you an example where it says wireless information transfer with opportunistic energy harvesting, right? And then, or else sometimes they can be long and descriptive, right? So normally in a letter paper, I have seen a short and a specific kind of titles, and in in original research papers, there could be long and descriptive titles. So you cannot tell that, in general, you cannot tell that short is good or long is good. It depends on the context, right? Sometimes what really matters is the title should correctly reflect, right? The title should correctly reflect whatever you have done in your research. If there is a mismatch between the title and the rest of the content of the paper, maybe the reviewers will complain, or readers who will subsequently read your paper in future will get confused and so on, right? Sometimes what you call try to put names, right? Names means words that stick in a person's mind that can be added. For example, I don't have a specific example. Let's say MIMO is multiple input, multiple output. So you that is some kind of a name that will stick to the mind of a person who is working in telecommunications fields and so on. So then later on, he or she might remember your title, and then later on, he or she might use it in their research and so on, right? So normally there are also words that normally we don't use in title, something like new, right? A new analysis or a novel analysis and so on. And also these kind of things come with experience. By, let's say, what you can do is you can read a lot of titles from the journals or conference papers that you target, and then try to adopt or try to practice with a good title, show it to your supervisor, and then improve and modify and so on. So it's kind of a practical thing that I would recommend you to do so. So then comes the abstract, right? So abstract is the selling point of your paper, and then you need to put a lot of effort when you are writing abstract. Often the journal under journal guidelines, you cannot write more than there's a word limit. You cannot write more than 200 words or 250 words and so on. You have to read the journal guidelines very carefully. And these days, all the paper submissions are done electronically. So what happens is, if your abstract is more than, let's say, 200 words, if the journal says 200 words, and if you have 202 even, right, you will not be allowed to submit, because the computer, the electronic system can easily count the number of words. So you will have to somehow reduce your abstract to that, to limit up to that 200 word mark. So it's very important to read the guidelines. So, and also normally you can define acronyms, right, in abstracts. Also, please read the guidelines of journals. Now, in my field, it's allowed to use acronyms, provided that you use that word very often in your abstract. In some journals, I don't think you are allowed to use acronyms in the abstract. But anyway, define the acronyms first time, and thereafter you can use it again if the journal guideline allows it in the abstract. And also keywords need to be listed below the abstract, right? And normally these keywords are important for searchers. That means other people who will look into let's say particular kinds of research or research work, they will type these words, and depending on these words and matching with your keywords, your paper might be selected to show to them and so on. So keywords are very important, and they should be carefully selected so that your paper will get a lot of visibility in the end. Sorry. So I think I have missed. I need to go to the previous one. Yes. So the abstract should include the purpose of your research, a brief description of your research, right? And most important, the results and the conclusions. So I know it's a challenging task to write all these things in 200 words or 250 words, but you should practice it, and then you should be able to do so. Because most of the time, the reviewers, when the paper is submitted, will read your abstract very carefully, right? And then he or she, the reviewer, will have some kind of an impression about your research immediately, right? So you have to state the problem, your approach, and your solution, and the main contributions of the paper. If you have a lot of several contributions, you can take the most important contribution of your research work and mention it in the abstract, as maybe a single sentence or 2 sentences and so on, not more than that, because you don't have space. So include little, if any, background or motivation, why you did this research, and so on. You can include that in the abstract at the beginning of the abstract. And the content in the abstract should not be repeated later word for word in the paper. Sometimes this is a common mistake that people do, right? People take the abstract and then put the same type of sentences in the introduction. That means in the first section of your paper and so on. So don't do that. It's not a good practice. So there are common mistakes. A common mistake is to consider the abstract as a brief introduction to the paper. As I mentioned, sometimes you just take the abstract and then put it in the introduction as it is. So don't do that. So using too many words can cause readers to miss important points of your paper. So these are some kind of guidelines that you can follow when you are writing abstract, right? Omitting a summary of results or conclusions can cause readers to lose interest. And also making a reference is in general not allowed, right? So normally in the abstract, we don't write references to other papers and so on. You only talk about your result or your paper, right? And make sure the English or the language that you write is perfect in the abstract, because that's the first place where people will have an idea, will get an idea about your research work, right? So then comes the introduction. So introduction is the most important part of the journal paper. That means the first section of your paper. So it's so you can break down the introduction into several paragraphs. So normally, I mean, I have recommended some guidelines. You don't need to follow this, but that is normally the standard practice that normally people follow. So the first paragraph is a place to give reasons why you do this research or the background of your research and so on, right? So the second and third paragraph normally contains a description of the background to the problem. That means, I mean, what other people have done and how your research relates to previous work and so on. So basically, it's a place to market or to advertise the novelty of your research, right? You can talk about previous works. I mean, not everything, like let's say the most salient or the most important references that you wish to discuss and so on, right? I mean, then I cannot say a final paragraph, but let's say the third, the fourth paragraph, you can write some clear statements for the goal of your work, right? So why you, what are the reasons that you have done this research, and then the contributions, right? What are the new things or what you have found out of this research that you want to disseminate to the your research colleagues across the world and so on. So it's very important that you structure the introduction in this kind of a with this kind of a strategy, because once again the reviewers and also the readers of your paper, they will first have a good read of the introduction before they decide to move on to reading the other parts of your research paper. And if you have not written this in an attractive and efficient manner, right, some of the readers and reviewers might not be able to follow the material that you have written in other sections and so on, right? So that can lead to a rejection in the case of a reviewer, or a loss of interest in the case of a fellow researcher working in the field. So, as I mentioned in the introduction, you can talk about what is the research problem, why it is so interesting and important, and is it a hard problem, right? You can discuss about all these things in the introduction. And also, why has it been solved before, right? What were the obstacles, what that prevented previous researchers of finding a solution, effective solution, and so on, right? And what are the key components of your approach, why your approach is attractive, and how you have formulated your solution, and all those kind of things you have to discuss in the introduction. And finally, don't be afraid to include any specific limitations of your research or related to this work in the paper, in the introduction as well. So basically the contributions can be listed as bullets, right? If you check certain journal papers, you can see them as introduced as bullets, right? And then the final paragraph, that means let's say the fifth paragraph can be something like this: a summary of organization of your research work, sorry, not research work, the paper, right? So normally you can start something with a standard sentence like the rest of the paper is organized as follows. Section 2 presents this, sections 3 and 4 discuss this, and so on, right? So that gives the reader some kind of an indication of the organization of your the paper, as well as what to expect in the upcoming sections and so on, right? Okay. So then I will not discuss this because it's very understandable from the title. In some journals, right, so you have a second section you can dedicate it to related work or to the literature survey. Whereas in some journals, normally that is included in the introduction, as I mentioned earlier. So it's up to you you can check the journal paper that you want to submit and then include it as a separate section, as section 2, or in the introduction, right? So that is related work. Then comes the main body or the text of your actual research, right? So a clear and important technical contribution should have been mentioned by the time reader finishes page 2, right? So up to section 2, the reader should be able to get that this paper has this kind of a technical contribution, so I must read the section 3, 4 and 5 and so on, right? So every section in the main body of your paper should have some kind of a story. That means you can describe it something like this section describes the system model of that is considered in this paper. This section describes the algorithm or the solution that is described in this paper, and so on, so that the reader will have an idea of what to expect when he or she is reading the remainder of that particular section. So it's a good practice.
Sorry to interrupt.
Yes.
Kindly summarize because our last speaker was waiting.
Okay, so I thought I'd be given 40 minutes. So I think it's, yeah, okay. So basically, there are things like that. So I will skip some of the things that should be going into the body. I think you will understand it's the most important part. And also basically, you should have towards the end of the main body, right? You should have figures, tables, algorithms, and mathematical analysis, and so on. So then what do you call the results are shown in terms of simulations and experimentation, right? So many journals and conferences expect experimental results, not only simulations and analysis. So if you have done so, you can report in the section which is mentioned as the results and discussion section. So so you try to show a comprehensive set of results to impress the reviewers as well as to the reader that who will eventually read your research paper. So you can include the, in terms of simulations, you can include the absolute performance and relative performance and comparisons with other papers and all those kind of things. Normally the figures should be written in a very, shown in a comprehensive manner, right? So you can use popular software to prepare your figures. And also you should carefully read the instructions given by the journal before preparing the figures, because certain journals only accept particular kind of figures. For example, some journals will accept JPEG figures, some will you have to give them in PDFs and EPS figures and so on. Right. So what I am suggesting is to read the guidelines of the journal when you are submitting figures as well. So, sorry, because there's no time to discuss about figures. There are very important aspects that you should consider when preparing figures, right? And I hope that you will understand. Some figures should be in color, some figures should be in black and white, And again, like in some journals, you need to pay money, fees to include color figures and so on. So you can decide what are the types of figures that you need to put. Then, of course, you can discuss the final section will be the conclusion section, and it provides time for authors to think about how it relates to the big picture, right? So, I mean, your results and how they are related to previous results, as well as to the advancement of the research topic in your field, right? So there are things that also you need to consider when you are writing the conclusion. So in general, it has to be summarized manner. I don't again copy the abstract. You have to rewrite the conclusions after you write the research. So and you should be able to include the main results. In some cases, normally we write it in a qualitative manner, and in some cases, to support those qualitative key findings, you can go for quantitative results as well. Right? Then you can include the future work, sometimes along with the conclusion and sometimes as a short section, so that it will supplement or complement the conclusions and the things that you need to do in future and so on. So often some postgraduate researchers, they will read this future work section to get an understanding of what needs to be done further down in this kind of topic, right? Okay. So then you have to give acknowledgements, because maybe your research was supported by various people, lab technicians, other colleagues, maybe they gave feedback and so on. So you need to acknowledge them. And let's say in cases of IEEE, there are specific policy and guidelines going to be acknowledged and so on. So then references also should be included, and depends on the type of, whether you it's a journal or a conference paper, right? Normally a full paper, you will have about 30, 40, 50 references, and in a conference paper, maybe about up to 15 to 20 references and so on. So with that, I think there are also styles that you should follow when you are referencing IEEE, IEEE style. And then that is the most popular the type of referencing styles that we use in engineering. And also maybe in some cases, sometimes we use Harvard, and so on. So these are some of the examples that we use, depending on whether it's a journal paper, whether it's a conference paper, or whether it's a book or any other technical publication, so on. So all these things can be downloaded from the web, and you can use them as guideline, as a guide to write references in your work. So appendices are also put at the end, because sometimes you have lengthy mathematical derivations which you don't want to put in the main body because it distracts others, right? So you can put them in appendices, so that whoever interested in finding how he got or she got this result can refer to appendices, right? So I think, I'm sorry, so with that, I think I can come to the last slide of my presentation. So in this presentation, I think I outlined the structure of journal and conference papers. I didn't talk much about thesis, but I think I gave you a glimpse or basic idea of what should be included in a thesis as well. So a good understanding of the structure of the publication allows you to present research in an effective manner, right? So you have to follow this structure, so that the research paper will get, first of all, it will get accepted and it will be read by many colleagues or researchers, peer researchers in your field. So ultimately, you might also get a lot of citations and recognitions for your research, right? Always check the journal and conference guidelines, because I mean, they will be up to date at time to time. So you have to get the latest one, as well as between journals also there will be minor variations. So you should exactly follow them. Otherwise, there will be some kind of a risk of rejection, right? So with that, I'm sorry that I took some time, more than what given. And I thank all of you for listening to my presentation.
Thank you, ma'am.
இல்ல இங்க பண்ணுவோம். Sir, am I audible now?
Yes, yes.
Thank you, thank you, sir. Thank you for all your suggestions that will help us for publishing our article in any standard journals. Our next session speaker is Dr. Regen Lee. He has received his BS degree and MS degree from National Taiwan University, Taipei, Republic of China, and the PhD degree from University of Texas, Arlington in 1980 and 85. In all engineering, electrical engineering. In 1985, he joined the University of Texas, Arlington, where he is currently a professor of electrical engineering department and the director of Energy Systems Research Center. He has been involved in the revision of IEEE standards 141, 339, 551, and 739 and DOT 3000 series development. He is a president-elect of the IEEE Industry Applications Society, a prominent lecturer of the IEEE IAS, a member of IEEE Fellow Committee, the Associate Editor of IEEE IAS and International Journal of Power and Energy Systems. He is the project manager of IEEE National Fire Protection Association collaboration on arc flash phenomena research project. Professor Lee has been involved in research on utility deregulation, renewable energy, arc flash hazards and electric safety, smart grid, microgrid, industrial Internet of Things, and virtual power plants, AI of load price and wind capacity forecasting, power quality, distribution, automation, demand response, power system analysis, short circuit analysis, and relay coordination, distributed energy resources, energy storage system, and plug-in electric vehicles, charging infrastructure design, AMI, and big data, online real-time equipment diagnostic and prognostic system, and microcomputer-based instrument for power system monitoring, measurement, control, and protection. He has served as a primary investigator and a co-primary investigator of over 100 funded research projects. He has published more than 180 journal papers and 290 conference proceedings. He has provided on-site training courses for power engineers in Panama, China, Taiwan, Korea, Saudi Arabia, Thailand, and Singapore. He has refereed numerous technical papers of IEEE, IET, and other professional organizations. Professor Lee is a fellow of IEEE and registered professional engineer in the state of Texas. Some of the recent awards and honors obtained by Sir is in the year 2021 is first place of IAS Magazine Prize Paper Award, IEEE Industry Applications Society October 2021, and third place of IAS Transactions Prize Paper Award, IEEE Industry Applications Society in October 2021, and Best Paper Award Journal of Modern Power Systems and Clean Energy in August 2021. I welcome you, sir. And the session is yours. You can start your presentation, sir, on authorizing and publishing our research work in IEEE.
Good evening, everybody. And
Thank you, sir.
Professor Hima has provided a very detailed discussion on how to write a paper. And so my today's presentation, I would focus on the IEEE side. How are you going to publish or try to write a paper, research paper, and publish in the IEEE conference or journals? And currently I am the president of the Industry Application Society. So the introduction is very good. Thank you very much. And it's a little bit okay. Well, probably that is 2 years ago. So currently I'm the president right now. And when you try to write a paper here, so that is give you some introduction. IEEE published more than 150 journals, transaction, letters on wide range of technologies. If you depends on your field of interest, then you will find a corresponding area inside, almost, you can find a corresponding area, research area inside the IEEE. So as I have mentioned before, the presentation will discuss the authoring an article and publish your research work in the IEEE. This is a two-step process. So when you try to author in an article, the first one is you have to look at it is what is your problem statement? What kinds of problem you try to solve and what is the motivation? How important is the problem to your research field? And what is your motivation to solve the problem? And then, of course, you have to ask Professor Hima mentioned, you have to understand the state of art through the literature search, because you don't want to reinvent the wheel. You try to look at it, what has been done, and then, of course, during the literature search, you will be able to understand what are the pros and cons of the current research, what kinds of assumptions they have to make in order to reach the conclusion in that paper, or what is basically the advanced in the field. And then you propose a new algorithm or a way to improve the outcome. Then, of course, when you try to propose that one, you need a theoretical background to support your proposed approach. You cannot just draw it from the sky and then dream it about it. You need a theoretical background and to convince the people this is the feasible approach or this is a promising approach. And then based on your approach, based on your theory, then and also your hypothesis, then you try to provide a case study, either a simulation, lab, or field testing. So on this way here, to show the effectiveness of the proposed approach. And then, of course, when you try to write an article and try to make sure just to report your original work. And there's some exception, some survey paper, and they basically summarize other people's work. They don't put in their work. So this is some exception when you try to write a paper. Okay, so as they mentioned, that on the title side, there have to be there's an echo. Well, there's an echo in the background. Okay, thank you. Okay, thank you. Yeah, for the title, you have to be specific and concise and descriptive. So you don't want to have a long title, and then when people look at it, okay, they basically they lost the. So you don't want do you hear the echo in the presentation? So yeah, if you are not talking, can you please mute yourself? Okay, and then on the abstract side, like the Professor Hima mentioned, you have a concise summary of the research conducted and what the highlight on your research and the conclusion. So normally there's a limitation. It's about 250 words or less. And then in the introduction, you try to give the problem statement and the motivation. And so you can have a literature review in the introduction, or you can have another section to try to discuss the literature review and what are the pros and cons of the current approach. This can also be included in the literary review. And then the one thing is the introduction is very important. You try to highlight the novelty of your approach and what you try to approve or what can you improve. So on that way here, because a lot of time people read the paper, then they look at the abstract and the introduction. These are two mostly two most important section in the paper, because if people read the introduction or read the abstract, they don't see any value of the paper, then they will skip it. So because in the research world, then you also like your research work to be referenced, the so-called citation. And then you try to mention what is your approach. How are you going to do? This is on the theory side. And what is your approach? What is the procedure? What are the results? Do you have a test case to prove your theory? And then also with the discussion and conclusion. Of course, when you write a paper or when you do some research, you are not going to solve all the problem. Okay, and then so you have to explain what does your research mean, result mean, and why they make the difference. And then what is the broader implication of your approach, and also what is the area for further study, because a lot of time when you write a paper, then you don't want to tell people this is perfect, and after I finish this paper, there's nothing left can be done. Okay, there are always something to be improved, and that is also give the reviewer the impression that you understand the problem and you understand the limitation. And then also in the area of future study, that also give you the opportunity to write the subsequent papers in the related area. And for this one here, I forget to mention, these are in the IEEE, okay? So IEEE Author Center.IEEE.org. So you can look at more detailed information about the author in the paper. And so you have to communicate clearly and concisely. And so you have to organize your material logically. So when you try, basically just like you try to write a novel, and then you try to tell people what is the problem, what is the motivation, how important is the problem, what has been done, and then what you try to propose, what is your proposed to do, and what is basically the theory to support your proposal, and then a case study to validate your proposal, and then the discussion. So on this one here, because from most of you are basically the English is your native. So, but however, the technical writing sometimes can be a little bit different. So if you have basically any doubt, then consider English editor service. And because some of the wording that the different culture has a different usage. And for the authorship, so who should be listed as the co-authors? And basically, okay, it's not that you try to put all the important name or the famous person as your co-author. That because a lot of time when doing the review, they are double-blinded, or basically a lot of the reviewer, they just look at the content. So the author should make a significant intellectual contribution to the theoretical development, system, or experimental design, prototype design. So in other words, that if you try to put people as a co-author, that individual should have a contribution to the paper. And or basically when they try to finalize the paper, okay, review the paper or revising of the intellectual contents, and so yeah, this is basically is very, very important. And then basically that individual either improve the theoretical part of the paper or improve the quality of the paper, then that you can consider use their name with their consent to list as a co-author. So if you have multiple authors, then you have to identify corresponding authors and provide his or her content information, because a lot of publication, they only contact or they only have a correspondent to the corresponding authors. And the corresponding authors, then should be that basically will be the point of contact, and then he or she should disseminate the information that he or she has received. So ensure all appropriate co-authors are listed, and then you have to give the consent, because you don't want to say, okay, well, I just this to somebody and as a co-author without their consent. Okay, so all authors are shared the responsibility for the contents of the articles. Okay, this is very important, either good or bad, because sometimes, yeah, my experience is that some paper come in and then they have been identified as a plagiarism, and then they basically the IEEE impose some penalty to the authors, and some authors say, okay, well, no, my name is there. Okay, so this is the basically it violates the publication rule that you have to obtain the consent of the all authors, and then also that basically, okay, every author share the responsibility. If you have a paper award, then if you look at it, if they have a monetary award, then they are equally divided. So in other words, it's good or bad. Everybody share the responsibility. Okay, so yeah, IEEE take the plagiarism very, very seriously. So you are using someone else's prior idea, process, result, or word without explicitly acknowledging the original sources. So the key is you have to acknowledge that you have using the information. So that is the purpose of the reference. So on this way here, then that basically, okay, you can avoid being accused of being plagiarism. And then, of course, when you try to do that one, sometimes you have to use other people's reference, or however, the main purpose of the publisher paper is publish your original work. And so you don't want to, okay, then you have to, when you do the copy, rephrase, or reuse, or adapt, then you have to attribute that resource. And every paper come in, now that basically the computer is so powerful, every paper IEEE received, they are going to perform a cross-reference, similarity check for all submitted articles. And then the other important issue is the fabrication or falsification of the result. Okay, because sometimes, okay, yeah, that people just report part of the result, and then, or they alter their research result. So they inaccurate reporting of the research conducted, the result and obtained. So it's basically the example is you modify the result. Okay, so and then you provide incomplete information, or you just say, okay, well, you do 300 testing or 10 testing, only one result, give you a favorable result, and then you just select the report of the result. So this is not acceptable. And then the other one is the data tampering or misrepresentation. And or when you try to present a figure, you manipulate the figure, or when you do the citation, and then it's a citation manipulation. So these are not acceptable. And then the other one is, okay, well, from the duplicate submission point of view, you only submit to only one publication at a time. And of course, that sometimes that when you write a paper, okay, so it's basically the subject that may fit multiple society or multiple committees. And you may want to basically try every one of them. However, when you submit the paper, you only submit one publication at a time until the decision is made. So, and then you also try to avoid submitting an article which is the same or very similar to previous published work, because on this way here, during the plagiarism check, then that it will be pointed out and then be rejected. Okay, so if you look at the IEEE guide, that you have when you try to submit a revised paper or improve the paper, that require a significant amount of the new material. And also avoid the plagiarism. It's very important to provide reference to prior publication and offer sufficient new materials, because on that way, when they check it, okay, because you already disclosed that some information is in the prior publication, so this will not be considered as a plagiarism. So this is the basically on the review and the typical review process. Once you submit the paper, okay, then the journal staff will basically check whether you have provided enough information, for example, the copyright release form, and also the format, and then pass it along to the editor-in-chief. So editor-in-chief will look at it, and they can reject based on the topic. They say, okay, this is not related to our society. So when you submit a paper, it's very important to look at what they're looking for. So you have to look at it, whether the topic is for example, in the Industry Application Society, we try to look at the other name implied. It's on the industry side. So if you try to submit a very broad, for example, the ultra high voltage transmission area, then the editor-in-chief may say, okay, well, this is outside our scope, the society scope, and he or she can reject the paper. And then the other one is the format, okay? The paper is too long, okay, or it doesn't follow the template of the paper. So IEEE has to provide all the paper template, and it's very easy to download. Then after that, the EIC, then basically the first initial check, then they'll pass down to the AE, the associate editor. And of course, inside the Industry Application Society, we have a technical paper review chair, okay, in between, and then pass down to the associate editor. So for the associate editor, then he or she will select the reviewer based on the topic of the paper, then select the reviewer that's familiar with these topics, and then basically provide the review, and then also there's a 3 selection: accept, revise, or reject. And if it is accept, then that will basically pass along to the EIC, and then he or she will make the final decision. So because the associate editor will make the recommendation, and in our society, the IAS, the TCPRC, will make a recommendation to the EIC, the editor-in-chief, and the editor-in-chief will make the final decision. And then if it's a revision, ask for the revision, then the author will have to look at the reviewer's comment and the suggestion, make the necessary correction, and come back to the associate editor for further review. And yeah, sometimes after two or three review, they will be accepted or rejected, because if the associate editor doesn't see big improvement, then the associate editor can reject the paper, can recommend to reject the paper. Okay, so this is the basically, well, in the IEEE site, we have a very good, the website, give you the recommendation. So you try to look at it, say, well, you try, if you look at the website, you try to look at it for the periodical, or you try to look at a conference, and you try to enter your title or a keyword. And so on this way here, that will give you that basically, publish the date you'd like to publish. As the Professor Hima mentioned, each review for the periodical paper, then each society has a different review period. And currently, we try to have a first decision within 90 days. Okay, so when you try to look at this one here, and then this publication recommender will give you some suggestion based on your keyword, based on your area of interest, and then that provides some suggestion. So on that way, then you can decide which journal or conference to publish, to submit your paper, research work. And yeah, of course, I always recommend, because before, you don't want to wait until this stage. Try to, after you finish the paper, you try to find where to publish. So the work should consider where to submit your publication should be much earlier. You try to look at it. Okay, if you are targeting in the Power Energy Society, or you're targeting in the Industry Application Society, or you're targeting in the Power Electronics Society or other society. So what you try to look at it is you try to look at the scope of the society work and what is the paper or the magazine article they are looking for. And then you try to look at it, whether this is the right place for you to submit your papers. So that important, the consideration about your publication, that is you have to submit to the journal that appreciate your work. Because if you try to submit the work unrelated to the journal, then it would definitely be rejected. So you have to submit to a journal that appreciate your work. And then that basically from the score point of view, that you try to look at the format of the submission, and you basically, okay, some people, some journal or some society, you can do a direct submission, and then or some society have a so-called presentation first requirement. And they also have a paper template. So it's very important to follow the paper template. And then, of course, from the submission point of view, from the research world, we also like to look at the impact factors. Okay, so you try to look at it. Okay, if you consider your paper is a very high quality paper, then you try to submit to the journal paper that with the higher impact factor, because normally you are going to attract a more audience. And if you consider your paper is basically, okay, well, that it's only just have marginal improvement, and then you try to present your work to other people's, then that you try to look at it, okay, different journal papers, and of course sometimes the journal will tell you their acceptance rate. And also currently there's a move try to have a so-called open access, and so your publication open access or it's a pay-per-view. And then also you have to look at what is average time from submission to online publications. And as I have mentioned, okay, it really depends on the journal to journal. And so, yeah, it's as I have mentioned, in the Industry Application Society, we like to have a timeline within 90 days with the first decisions. And some journal, the author have to pay, and some journal that, especially for the open access journal, a lot of time author has to pay. And for some pay-per-view journal, then the reader have to pay. So that it's basically, okay, well, when you try to submit a paper, you have to understand, do you have an extra cost, or this is basically, okay, from the quote unquote free to the author. And is there any page limit, and how much is overpage charge? Okay, so for example, in the Industry Application Society, our limit is 10 page for the journal paper. So each additional page is $120 per page. Okay, so yeah, I will try to use a little bit time to discuss on the Industry Application Society. Okay, IAS is the 6th largest society within IEEE. We have 14,000, more than 14,000 members. And we basically, okay, well, if you look at it, because our name carry the industry application. So it's a world leader in the advancement of the science and technology, the theory and the practice. So if you try to write a paper, submit to the IAS, and it's very important that you link the theory to the practice. All right. So it's an important part. And the mission is that basically we re-emphasize theory and the practice. All right. So on this way here, we even in the value statement, we also emphasize on the theory and the practice. So you don't try to write the paper that is the pure theoretical one, because it's maybe acceptable in other society or other publication. However, if you try to submit a paper to the Industry Application Society, it's very important to link your theory to the practice. And yeah, here we have a 6 we have a 4 department, and you can see here for the Industry Application Society, we cover a wide range of the topics. Okay, you look at the process industry, you look at industrial power conversion, that's related to the power electronic side, industrial and the commercial power system, that related to the power system to the industry application, and you also have a manufacturing system and the development. That is the lighting, okay, electrostatic, and the industrial automation and control. So yeah, if you look at the color coded here, it's for the red and green, that the attend the IAS annual meetings. So every year we have an annual meeting, and then it's a paper presentation. So for the committee, I highlighted with the red and the green, they attend the IAS annual meeting. And then for the blue one, they join the ECCE. For the black and green, they all organize its own meetings. So you can see here, there's a lot of opportunity for you to publish your research work in the Industry Application Society. And we try to modernize and enhance of the current technology. We try to bridge and lead in the emerging technologies. Okay, so we are heavily involved in the smart grid, smart city, and the smart manufacturing, and also the renewable energy, DER, energy storage system. And yeah, recently people also talk about the zero carbon emission, okay, the decarbonization, because this is a very important topic for the industrial sectors. And then with the online shopping, okay, there are a lot of data centers that has been established. And this is also part of the scope of the IAS. And of course, the Industry 4.0 is definitely within. And from the 5G technology point of view, we are not working on the technology by itself. We are working on the application side. So how are we going to use the 5G technology to improve the operation efficiency, or basically that reduce the cost of the industrial operation? And then the robot, UAV, unmanned vehicle technologies, AI, okay, the AIoT, the IIoT, that the industrial IoT system, deep learning, machine learning, that is always try to improve the efficiency of the operation. And then the most recent one on the power electronic side is basically how are we going to use wide bandgap semiconductor on the smart lighting. And then from the industrial power system point of view, for example, in the microgrid system, how are you going to use the power electronics from the grid following to grid forming? Okay, so in 2020, that we have sponsored, okay, because of the COVID-19 original application, we have a 70 application for the IAS, either financial or technical co-sponsor conference. And yeah, unfortunately, due to the COVID-19, and the actual number dropped down to 54. So one canceled by IEEE, and that about 6 canceled by because of COVID-19, and then also 9 of them moved to the 2021. Okay, from the IAS publication point of view, so that is we do have a so-called presentation first policy. You have to present your paper in one of the IAS sponsor conference. And then from there, they're going to go through the further review for the transaction on industry application or the industry application magazine. And we also have a direct submission. You have open journal of industry application, or like that Dr. Hima mentioned, that we also have a special issues. And on that one, that is a direct submission. For the open journal, that author pay. All right. If you have a special issue, then that's a reader pay. Okay. So this is a difference between two submission route. And we also have a joint publication that a transaction on transportation electrification, transaction on sustainable energy, and also the electrification magazine, and the transaction on smart grid. So this is our joint publication with other sister societies. And currently give you the impact factor, because on this one here, you look at the transaction of the industry application, that in 2020, our impact factor is a 3.654. And so, of course, the impact factor is not the only index that you try to judge the paper. However, it's basically, it provides provide you some idea the quality of the paper, and normally you try to look at a paper if the publication, if their impact factor is above 3, then they consider it's a quality paper. All right. So as I have emphasized, okay, this is not the only index to look at it. And then the other one is, okay, well, when I try to look at some opportunity inside the IAS, you can do the standard development, because the standard development is also a research. And also you contribute your expertise, you work with your experts, the every subject matter expert. And the currently IAS has 76 active standard. And so we have a system level 1, we have installation level standard, we have equipment and operation level standards. And as you have heard the introduction to myself, I have been involved in several standards, and the most recent one is the IEEE 1584, that the ACFRASH standards. And our group had developed all the estimation formula, that the equation used inside the standard that had come from our research group. And yeah, we also have an award. Okay, so we award a young engineer, and also some long timer. And so we try to bring in the next generation and the current generation engineer together. And then so the IS will have a sustainable development. And so you can look at it on our website. We have a lot of award, and try to award your contribution to the IAS. So with that, I'm going to stop it here. And if you have any question, that I'll be more than happy to answer. And on this one here, okay, if you scan the QR code, you can get my basic information, the contact information. So if you have any question, you can send me an email. Thank you.
Thank you, sir. This is Ravindra, sir. Hello, sir.
Yes.
Okay, sir. Nice. You have given nice presentation, and participants will benefit for their research and IEEE. So I would like to invite you in person to our campus, sir.
Okay, thank you. Yes.
Sir, as per your convenience, so I would like to invite you in person. So I will arrange all the travel and all the accommodation. So
Okay.
please come to our campus. So we would love to have you, and our participants is very fortunate that they listen to you. Our EC HOD is there. Professor Uma ma'am also is there. So, ma'am.
Yeah,
Yes.
good evening, sir.
Yes, thank you.
Sir, your presentation is very nice, very informative. It is very useful for students, sir. Actually, we are very much interested in publishing in IEEE transactions and journals. In future, with your guidance, whatever we got information from you, definitely we will publish more papers in IEEE. In future also, we want your support and cooperation for further improvement of our students and faculty improvement. Thank you so much, sir.
Sir,
Okay. Thank you
sir,
very much.
in this workshop, we are trying to cover all the research area, research methodology, research gap, citation, plagiarism, and bibliography. So all the things we are trying to cover, and many speakers giving their speech. Yesterday, Professor Saad Makelev speak citation, okay, sir, and bibliography, ethics. We're trying to cover almost all the area of the research methodology. So, sir, if you come one day in our campus, it will be very great to us, very grateful to you if you come to our campus, sir.
Okay, well, thank you very much for the invitation. And the other thing I would like to provide opportunity to your student is in this year, the IAS annual meeting, then we provide a student travel grant for the student to attend our conference. And it's going to cover probably not all the expense because that depends on the different location. The airline ticket, they'll cost differently. But once they arrive, we have some subsidize on that part. And then once they arrived, then the registration is free, hotel room is free. So that is, and then also we basically cover all the meal. And so if you are interested, you can go to our website on the annual meeting website, and also our main website. They have the CMD, the Committee of Membership Development, and we are going to cover up. It's between 100 and 125 students to attend our conference. So if the situation permit, because right now the COVID-19, that the situation can change anytime, but yeah, we try our effort and then try to include the student or give them the experience to attend the conference. Because when you attend a conference, you will see you feel different because you are in person over there, and then you will be able, you have the opportunity to listen to other researchers' report. And I always tell people, when you attend a conference, you have 3 objectives. The first one, you try to listen to other people's research. And then the second one is you try to attend the committee meeting. So you understand what is the operation of the society, because the event, if you are interested, you can get involved. And then just like myself, I have been involved in IAS for about 35 years. And then that become an officer of the society. Okay, so you understand the operation because you attend a conference. Okay, and then of course behind the conference, to make the conference happen, a lot of people are devoted in the work and then make it happen. And then the third part is you can also attend the working group meeting. The working group meeting is they are working on the standard. So that is basically that's an opportunity for the student to mingle with or networking with the subject matter expert, and then they will be able to do a research and more meaningful research. So this is the good opportunity for the student.
Thank you so much, sir.
Great opportunity, sir. So we will circulate this information to our student group, student WhatsApp group and emails. So we will circulate this information to our all the student group of engineering stream.
Okay.
Thank you, sir. Thank you, sir. Once again, sir. Sir, it is great.
You're welcome.
Great opportunity to for our participant to listen you.
Yeah, it's my honor, pleasure to discuss with everybody on this subject, and then hopefully it helped.
Yes, sir. Yes, sir. Yes, sir. Sir, please come to our university once you have time, as per your convenience. So please come. I would like to invite you, sir.
Okay. Yeah. Thank you. That yeah, I would basically once the situation calm down a little bit, that I can resume my travel. Yes. Yeah. That would definitely it will be on my list.
Yes, sir. Yes, sir. Thank you, sir.
Okay. Thank you very much, and everybody have a nice night. And so
Thank you, sir.
yeah, hope to see everybody in person and
Yes, sir.
somewhere either in the US or on your campus.
Yes, sir. Yes, sir. Yes, sir. Sir, we are waiting for you in our campus.
Okay.
Waiting for you.
All right. Thank you.